The first one is multiplication of complex numbers. A complex number times a complex number should result in a complex number. If you get something else, well, sometimes you get a real number, but a real number is still a complex number. But you shouldn't end up with a polynomial here. What do I mean? Well, you have a binomial times a binomial, so you would FOIL it, yes. But at the end, where you have an I squared term, you can't leave that as I squared. Let me show you what I mean. All right, we know that a binomial times a binomial is something we use the distributive property to multiply or FOIL. So if you do first, you have 2 times 3. And 2 times 3 is 6, but I'll write 2 times 3 here. I'll show every step. And then 2 times negative 2i. That's our outer. Our inner will be 5i times 3. And our last will be 5i times negative 2i. And doing this, we get this, we get this, we get 15i, we get negative 10i squared. If you combine the middle terms, o and I, you get 6 plus 11i minus 10i squared. But you don't want a polynomial here. That's what I was saying. You should end up with another complex number. So what do you do with this negative 10i squared? You say I squared is negative 1. And you go, well, cross that out, make that a plus, because negative 1 times 10, or negative 1 times negative 10 is positive 10. So that becomes plus 10. And since I'm adding 10, I'll just put a 1 here. Does that make sense? Another way you could set it up, and then you could do this times 3 minus 2i. 2 times all that is 6 minus 4i. 5 times all that is 15, but there's an I in there, so 5i times all that minus 10i squared. And then these, you can just go boom, changing that. 6 plus 10 is 16. Negative 4 plus 15 is positive 11i. So it doesn't have to take a lot of steps. You can do some stuff all in the same step. Okay. Down here, if we're going to divide a complex number, we have to do that by multiplying by the conjugate of the bottom. The conjugate here is 2 plus 3i. So I'm going to do that to the top and the bottom, because if I didn't do it to the top and the bottom, if I use something else on top, I want to be multiplying by 1, and then I would be changing the value of the original problem. And I don't want to change the value of it. I want to figure out what the value is. So how do I do that? I multiply by 1. Multiplying by 1 allows me to simplify the problem. So we put an equal sign. On the top, it's going to be 2 plus 3i, because I'm doing 1 times this whole thing. First, outer, and then my inner last is 2i times this whole thing, so it's 4i plus 6i squared, all over. And I'm going to show you something here, but you can skip the step once you realize it always happens. If I do 2 times this whole thing, I get 4 plus 6i. And if I do negative 3i times this whole thing, I get negative 6i minus 9i squared. Now, 2 things always happen in the denominator when you multiply by the conjugate. The first thing is that in your f, o, I, l, the middle terms always cancel out. Why is that? Because we multiply by a conjugate pair. And that is why this times this always comes out to x squared minus y squared, right? No middle term, because the o and the I always cancel out. So that's something to keep in mind. The other thing that always happens here is that you know that if, actually let me go like this. What I just had up there a second ago. But let me add an I. Oh. Actually, even better, let me do it with the standard form of a, they like using A's and B's. So The conjugate of that is this. If you multiply doing the FOIL, you get a squared minus abi plus abi minus b squared I squared. These two always cancel, but b squared times I squared, well, I squared is negative 1, so negative b squared times I squared is a squared plus b squared. See, in intermediate algebra, they told you that a sum of squares is not factorable. It isn't over the real numbers, but with complex numbers, you can factor it. It comes out to a conjugate pair with a I on the second term. Okay, so let me do this. What do I see here? I'm going to take the green, and this makes this term here a plus. So it's 4 plus 9 is 13. So the bottom is going to be a 13. By the way, that always happens. What's 2 squared? 4. What's 3 squared? 9. So what's the bottom going to be? 4 plus 9, which is 13. That'll always happen. What happens up top? This I squared makes this a minus 6. So now I have 2 minus 6's negative 4. And then 3i plus 4i is 7i. And so what can I say that is? Well, I have to write it in standard form. So I distribute the division, and I get this plus 7 over 13i. And that's my answer. That's how those are done. I hope you got it. Oh, I went way over. I'll have to edit this. Hope that helps. Number 2